Okay, we've got a situation where we've got buses, and the buses are leaving every 15 minutes. Okay, Alex is arriving at the bus stop, and she's not planning to arrive at any particular time. Okay, so that could be any time, and the random variable that we're interested in is her waiting time, the time in minutes that she has to wait. Okay, in the first part of this question I have to explain why this could be a rectangular distribution. Okay, well, a rectangular distribution is when all outcomes between A and B are equally likely. So I have to say what A and B are, and I have to explain why it might be sensible to say why all of those are possible and likely and nothing else is possible. So let's do it. Okay, so how long might she have to wait? Well, it could be she's really lucky and there's a bus there at the instant she arrives at the bus stop. So it could be that she only has to wait 0 minutes. Okay, but it could be the bus has just left and the buses are every 15 minutes, so the most that she could have to wait is 15 minutes. So it's clear that she won't have to wait more than 15 minutes, and obviously she can't wait less than no time at all. So I think I've got my values of A and B. Okay, and now I've just got to explain why this is the case. So I've done part of that already. I need to write it down, but she can't wait more than 15 or less than 0 minutes, and because she is not planning when she arrives, she's equally likely to arrive at any time, which will cause her to wait for anything from 0 to 15 minutes. So there's the first point I need to make about all times between 0 and 50 being equally likely, and why? Because she doesn't plan. Okay, and the other point was the one about times outside that being impossible, and that's because there is a bus every 15 minutes. So therefore, it is rectangular on the interval 0 to 15, okay, which I've kind of said already with A and B, but B equals 15. So I've definitely done everything I need to for that part A. Now I've got, in part B, I've got to calculate the mean and the standard deviation of her waiting times. And for this I need to look at the formula book, page 11. So here's the bottom of page 11, the rectangular distribution, here it is. The probability density function mean and variance are here, and I'm doing the mean and standard deviation. So I need a half a plus b for the mean and a 12th b minus a squared for the variance, and I mustn't forget to square root that for the standard deviation. So applying those two formulas to the mean, a half of a plus b, a half of my a and my b are the endpoints of the interval, so that's 0 plus 15. A half of 0 plus 15 is 7.5, as you'd expect. And for my variance, I need to do a 12th of, and this is now b minus a, so that's 15 minus 0 squared. So the variance is 15 squared divided by 12. Okay, 15 squared over 12 is 75 over 4, or 18.75. So that's lovely for my variance, but the question, remember, asked me for standard deviation. So therefore, for the standard deviation for my sigma, I need to do the square root of the variance, 18.75. So square root of that answer on the calculator gives me as a decimal 4.330. 4.330. Okay, so I've got a mean and a variance, two clear answers. Good. Back to the question, what was part C? Part C was find the probability her waiting time is between 6 and 8.5 minutes. So now I need the diagram. Okay, so the rectangle for this rectangular distribution goes from 0 minutes to 15 minutes. Okay, so the first thing I need to do is to work out the if you like, the height of this rectangle. I know that this is 15, okay, and so the height must make the area equal 1, okay. So I could go back to my formula book, because this 1 over b minus a, the probability density function, is exactly what I need to tell me the height of the rectangle. So this height is going to be 1 over b minus a, 15 minus 0, which is 1/15th. So we've got a rectangle that is 1/15th high. Now, I didn't really need the formula book. This is obvious because the total probability, if I sum up all of this probability, I must have a total area of 1. And so 15 times 1/15th is what I need to make 1. Anyhow, as long as I've got this height of 1/15th, I can now work out any other area that I might be interested in. And in this case, that was this interval of 6 to 8.5 minutes. So that means that it's really just the area between 6 and 8.5 that I'm interested in. So my probability that I want is this area here. Okay? Well, how am I going to work that out? Well, this is just another rectangle. And it's still got this height of 1/15. It's shorter. How long is it? Well, this gap is 2.5. So I'm doing 8.5 minus 6 equals 2.5, gives me the gap. So therefore, the probability is 2.5, the length of the rectangle I'm interested in, times its height, which is the 1/15. So I need to do 2.5 times 1/15, which on my calculator, it gives me decimal, it's 1/6, it's 0.1666 recurring, so equals 0.16667. To correct to 5 significant figures should be good enough for anyone. Okay. Then for part ERD of the question, okay, we want the probability that she has to wait exactly 7 minutes. Now this should remind you of when we did this with the normal distribution, okay? So I could draw it on here. The probability I want is the area covered by a time of exactly 7 minutes. But that would just be a straight line, and a line has no area, okay? It's the same reasoning as for normal distribution. The probability of being exactly 7 minutes is 0, because if you could measure it accurately enough, it would turn out that any time you thought was 7 minutes was really 7.000000001 minutes. So, we just write down the answer as 0 for part D. Okay, part E. We've now thinking about 7 days in a week, and we're finding the probability she has to wait more than 10 minutes, okay, and then that happens on 5 or more of these days. So what we're now seeing, in the A2 course, they start playing these games where they call on us to use some of our other knowledge from last year as well as what we've just learned. So there are two things going on here. The first thing is this more than 10 minutes business. So let's start with that, and let's forget all about the fact that this is 7 days in a week. So what's the probability of more than 10 minutes? Well, that's just a different area in my rectangle. So I want to be more than 10 minutes, so that's anything from 10 up to 15 minutes. Okay, so that's a rectangle that's 5 long and 1/15 wide, so it's just 5 times 1/15, which I can do in my head, that's 1/3, or 0.3333 recurring. Okay, so that's the probability of waiting more than 10 minutes. But now the rest of the question was about what's the chance that that will happen on how many occasions in a week. Let's go back to the question. Here we go, it was on 5 or more of these days, in other words 5 or more out of 7. So what have we got here? Well, we've got a week, so we've got 7 independent days, okay, and on each day there's a chance of 0.333 that she'll have to wait for more than 10 or more minutes, okay? So we need to recognize this as being, we're counting the number of successes, if you like, in n independent trials, where there are 7 trials, so this is binomial. It's a binomial with n is 7, because there are 7 trials, 7 days in the week, and the probability each time of having to wait at least 10 minutes is 0.33333, so that's my value of p. So if I want to write it as a notation, it's b brackets, n is 7, and p is 0.33333. Sometimes they ask you to define the distribution, so you write something like this. Okay, so I now need to find the probability that this happens 5 or more times in the week. So on the probability that x is greater than or equal to 5, where x is this binomial thing here. So, remember with binomials, we list the outcomes. So it's 0, I'm interested in 5, so I'm going to be interested in 4 and 6, and it could be anything up to 7. So, I want 5 or more. So that's 5 or 6 or 7, not any of these. So, box contains everything. Oh, well, that's going to be 1. And then get rid of the ones I don't want. That's everything up to and including 4. So I need to do 1 minus the probability of x being less than or equal to 4 from a binomial with this n and p. So this is just like S1. So on my calculator, okay, distribution mode, binomial CD, okay, variable, I've got an x value of, I want less than or equal to 4, so I use that as my x, and my n was 7, and my p was 1/3, 1 divided by 3 will give me the 0.3 recurring, and it tells me the answer to that is 0.954. So remember, I had a 1 minus in mind. I need to do 1 minus the 0.95473, which is 0.04527, and that's my answer for part E. So just one more to go. I have a part F. What was part F about? Back to the question. So part F is asking me, okay, she's now already been waiting 5 minutes for the bus, and I need to find the probability she's going to have to wait at least another 5 minutes. Okay, so we can go back to our rectangle. So our rectangle was always a rectangle from 0 to 15, okay, with height 1/15. But that's changed now, because this first part of the rectangle, she's now got to this stage, 5. So this part of the rectangle no longer applies. So she's now waiting sometime from when she first started waiting, it's going to be sometime between 5 and 15 minutes. So I've got a new rectangular distribution. Yeah, the times between 0 and 5 aren't possible anymore, because she's already been waiting 5. So now I've got a new rectangle. The length I can see of this rectangle is 10. I'm not going to bother with the formula book, because I can just see the height. To make the area 1, the height is going to have to be a tenth. The formula book would tell me to do 1 over 15 minus 5, and it would give me a tenth, so I could do it that way, but I haven't. And I want to find the probability that she will have to wait at least another 6 minutes. Okay, I think the question, as you will have it, says 6 minutes here, not 5. Okay, so I've put that right. So therefore, I need to be in the part of the rectangle where she needs to wait at least another 6 minutes. So she's already waited 5 minutes, so that means we're really interested in times from 11 minutes to 15 minutes in terms of her total waiting time. Yeah, this is an extra 6 minutes. And I'm interested at least an extra 6 minutes, so I'm interested in that bit there. Okay, let's do it in colour. So it's this black shaded bit here between 11 minutes and 15 minutes, and that's another rectangle. So its probability is just the area. So the probability is going to be a tenth, because that's the height of the rectangle, times its length, which I can clearly see is 4. 15 minus 11 is 4. So it's a tenth times 4, which is 0.4. So that's my answer to part F. So that shows you how to cope if they tell you, actually, some of the values we originally thought applied don't apply anymore. You just change the height of your rectangle. All outcomes in the new range are still equally likely. So I hope that helps.